Professor Uchida will give a presentation about the determination of unique power conversion efficiency of solar cells showing hysteresis in the IV curve under various light intensities.
Okay, thank you, and thank you for organizing committee, especially Monica Sensei. Yes, I know this is a kind of European community, but I hope my talk will be contribute to for understanding of the solar cell. Yes. The title is a bit longer, complicated, but just the same as recent publications. And today I focus on the low light intensity evaluations. This paper is very funny because the main article has only 3 figures, but supporting information have 12 figures with 3 tables because I fought against the referee alone almost half years to prove how to evaluate, and so on and so on. I showed the evidence there, and then finally it became a huge supporting information. Yes. To evaluate such kind of ultimate conditions, before the solar cell, we have to construct the simulator first, because you know very well, xenon lamp is not sufficient for our purpose. Yes. Yes. The construction is very unique, with having 31 kinds of LED bulbs, with 54 bulbs, and each of them are focusing in the aligned on the like a dome shape to keep the same distances, and also each of bulbs are equipped with the collimator lens to make a straight like a parallel beam to homogenize. And after that, of course, we can tune the spectra with our request in any shape. This is the, sorry, hard to read, but spectral matching is very nice, within the 5% for accuracy for our request. This is the data from 400 to 800, but finally we extended up to 900 nanometers. Within the accuracy, if 5% means like a 2 light source solar simulators. I think one of the highest level. And area uniformity is also nice. In the center part, especially the intensity is ranged within 2% error. Very, very, very accurate. And this is one example. For our purpose, we are keeping the same, the 1 sun or air mass 1.5 as a benchmark, and then just control the intensity only with keeping the same shape. Yes, in the menu, machine potentially available up to 1 by 1 million sun. Yes, 7-digit range, very hard to say. Special, and only one part, in that case, only one part has a bit exceeded 7.5 for error, but most of them are within the error 5%. And, okay, this is my desk. Yeah, a bit complicated. I always put the report from my colleague, Ludmila, and then, yes, it already 3 years ago, 2 or 15, February 10th, she showed, okay, normally 1 sun is 100 milliwatt per square centimeters. We already expected this perovskite may have a bit higher performance and reached 22%, 20%, something around. Very happy. Okay, let's try to more severe conditions. And confused, because cell performance reached 100%, and sometimes furthermore, something wrong. Yes, I confused because on the parallel, we also evaluated the crystal silicon solar cell and showed that nothing was strange. There are no mistake for machine, no mistake for measuring protocol, but I couldn't believe that this data, cell performance over 100%. And after, okay, this is the summary, a bit busy data, I'm sorry, but I explain one by one. In the case of solar cell, okay, the red part, okay, at the moderate intensity condition, like a 0.1 sun or 1 by 100, nothing happens. Yes, there are a kind of linear trend, slightly go up, but slightly go down. But after the reaching at a certain level, suddenly, you see, the cell performance reaches 100%, something wrong. Because this is a reverse scan. That means hysteresis suddenly appears. And therefore, the scan, a bit also strange. Yes. In the similar manner, the perovskite also has the same tendencies. At the moderate intensity conditions, it shows, I believe these are reliable data, but finally it goes up to cell performance 10,000, 1,000, something around. And you see the blue line is crystal silicon solar cell, shows a kind of linear trend, especially for JSG, gives a very nice straight curve. Yes. Last year, in the same conference, I already shown the hysteresis mainly comes from the capacitance, the junction capacitance. Because during the IB scan, the charge-discharge phenomena happens and finally affect on the IB shape. And then, now it's easy to understand. Oh, okay. No, sorry. Now you can understand, because you see, at the high intensity condition means high current conditions. Such kind of charge discharge current don't affect so much. Yes. But if you decrease the intensity, the number of the capacitance don't changes, and finally at a certain point it affects. Yes, the fake current may overlap, and then it's a kind of a definition issues. You see, I understood the IB measurement is not how to say, cannot provide a true performance at such kind of ultimate conditions. That's why I changed the MPPT machine. MPPT tracking, and there are several protocols. And then, yes, I requested another SPD company to make such a very nice machine, PV analyzer. Yes, always the machine trace actively track to the Pmax to catch up the true performance. And then, yes, we can tune the 4 parameters, VOC, the frequencies and the intervals and the starting voltage, something. And some people still complain, okay, even for MPPT machine, the people may sometimes recognize the short range IB curve. That's why it's not the final answer, some people say. Yes, it's true. That's why, for our purpose, the machine was tuned, specially designed for perovskite, to have two amplifiers to dynamically push out, balance the voltage to avoid the leakage inside the machine and also leakage inside the device. That's why, without current loss, we can monitor the current during the observations. So this is one example for time against performance. The Pmax, in this case, in our machine, it reaches stabilized within 1 minute. and keeping the same Pmax, about 40 minutes in this case. Okay, this is the final result in the comparison. The performance by IB measurement, and this is the performance by MPPT. Oh, yes. You can see in the crystal silicon don't have a hysteresis, don't have a capacitance, and show the same number. But in the case of solar cell or perovskite, shows a kind of not linear, but I think very natural trend. And now I have 2 minutes. Right? Before I finish my talk, this is one kind of summary. I show you 2 slides. In the case of perovskite, in the ultimate conditions, like 0.00325, yes, the forward scan start from the negative range. That means it is a kind of evidence there are capacitance, yes, by IB measurement, not MPPT. And also, in the case of silicon, yes, the silicon, in our case, couldn't observe the cell performance so much lower intensity because the voltage drop is much faster than organic photovoltaics. And that means, yes, crystal silicon has a limitation for such kind of low light intensity conditions. They stop the power generations. Okay. So, yes, conclusion, I think no need to explain too much. But hysteresis comes from the capacitance, and finally that affects on the cell performance evaluations. Okay, now I think time is coming. The group photo was updated. Yes, we enjoyed the skiing in the Zhao Ice Mountain. Thank you for listening. Thank you very much for kind attention.
Okay, any questions maybe?
Actually, it's not a question, a comment. I think your results are very relevant to the paper published by Monica and Crosses last year in Nano Energy. They studied diurnal dependence and also observed in a very low intensity, unusually high, and they also suggest a model for that. I understand that when you measure MPPT, you don't see this. But maybe it's good to reconsider this, because they suggested this model that at very low intensities, there are 2 contributions. One is photovoltaic effect, and another one is like battery. And this battery becomes. But I don't insist on it, but I think it's good if you consider this paper.
Thank you.
It's very relevant.
Yeah. Good advice.
Now I need to see how to get the microphone to you. Maybe. Yeah.
Something is missing. Okay. So thank you for your nice talk. And I have one question concerning, so if I understand you correctly, so on the low light level, so you keep your distribution of light that reach your solar cell surface the same, and you just decrease the intensity of light. I'm just wondering, have you tried in your experiments to do the changes in the spectra, the reach of solar cell surface, and if you try, what kind of are conclusions? Because you mostly in the low light level, the spectra are, by changing the spectra they reach a solar cell surface, you can change efficiency of your cell a lot.
Yeah.
And yeah.
You are right. It absolutely depends on the shape of the spectra for the light source. And in our case, you see, there are, for example, like IEC committees, they have definitions with different, maybe for each, no, in our case 50, but in the IEC standard defined with different 100 nanometers for each. For each wavelength, this is air mass 1.5, have a 9.7%. And we are keeping these ratios for each intensities. Yeah. That is our trial. Yes. I don't say this is a definition or something like that.
Okay,
Yes.
thank you. Maybe we can
Yes.
discuss.
And always try to minimize the spectral matching for less. Yes. Yes.
Okay, thank you for your presentation and your answers. Thank you very much.
Thank you very much.